Hello and welcome to Flipped Harbor for Algebra 2. In this video we're going to be going over section 1.4, simplifying algebraic expressions. Now our objectives for this lesson are to simplify and evaluate algebraic expressions. During the lesson we're going to look at translating words into algebraic expressions, we're going to be evaluating algebraic expressions, and we're going to be combining like terms. Then we'll do some examples and we'll finally end up with the homework problems. Now, translating words into algebraic expressions is probably the toughest part of this lesson. One thing to remember is that expressions have no equal sign. We're not talking about an equation here, we're just talking about an expression, which is kind of like half of an equation. Now, what you need to do is focus on key words. What's the language suggesting as far as our mathematical action? Words like total or combined suggest addition. Words like difference, remaining, or how many more mean subtraction. A lot of times when the book wants you to multiply, they'll use the term all together. And whenever they ask you how many in each, maybe how many in each group, how many in each class, or if they're talking about a rate, that's division. Now a rate is something like miles per hour. Whenever you've got a rate like that, you're literally taking something like miles and dividing by time in hours. Now we want to write an algebraic expression for the number of seconds in n hours. A statement like this, they give us the letter to use, they give us our variable. When they do this, we should not change it. We should leave it n, we shouldn't use any other letters in there at all. Now since there's 3,600 seconds in 1 hour, that means that the algebraic expression 3,600n tells us the number of seconds in n hours. Now let's look at evaluating algebraic expressions. What they're going to do is give us an algebraic expression and then give us some numbers to plug in for the letters. So for example, they want us to evaluate 3x squared plus 2x minus z squared for x equals 2 and z equals 1. So we go ahead and substitute 2 in for the x and 1 in for the z. Now the most important thing to remember here is the order of operations. I know you've done it before, but let's take a quick look again. For the order of operations, remember PEMDAS. Please excuse my dear Aunt Sally. The P stands for parentheses, so everything inside parentheses is done first. Then exponents like squares and cubes. Then we multiply and divide from left to right. And then we add and subtract from left to right. So let's get back to those expressions. When we want to simplify an algebraic expression, really this breaks down to 2 steps. Now there can be more, but these are the 2 big steps that we need to always follow. One, we need to get rid of parentheses. Now that usually means that we're going to distribute in either a number or a letter or a whole term that's both a number and a letter. Once all of those parentheses are gone, we want to combine like terms. Now when we talk about like terms, we're talking about those things that are added or subtracted that have the same variables raised to the same power. So you're looking at what has the same letter with the same power on those letters. Now here we've got an example where we need to simplify. The first thing we're going to do is get rid of those parentheses. We're going to do that by distributing in the -3. After we distribute in that -3, we want to go ahead and combine like terms. Now 2 of these terms are alike, the 3xy and the -11xy. So we're going to combine them. So we end up with -6x minus 8xy minus 9y. General practice is to put the terms in alphabetical order. -6x comes first just because x comes first in the alphabet. Now let's start taking a look at some examples. This is a pretty big example actually. It starts out taking a story and we need to create an algebraic expression from that story. And then after that we're going to actually substitute in a number. So Eric is baking muffins and bread. He wants to bake a total of 10 batches. Each batch of muffin bakes for 30 minutes. Each batch of bread bakes for 50 minutes. They tell us that we should let m represent the total number of batches of muffins. So they're giving us a variable to use. Again, don't change that. They want us to do 2 things. Write an expression for the total time required to bake a combination of muffins and bread if each batch is baked separately. Then they want to know if Eric makes 2 batches of muffins, how long will it take to bake all 10 batches? Now, let's start with writing the expression. We know that muffins take 30 minutes, bread takes 50 minutes. So 30m is the time that it's going to take to bake all the muffins. 50 times the number of bread batches will give us the time for the bread. But we're not going to use another letter like B for bread. We're going to use 10 minus m. That is 10 batches total minus the number of muffin batches. So we've got a start to our algebraic expression. What's left is to simplify it. We're going to distribute that 50 through, and now we need to combine like terms. So our simplified algebraic expression is 500 minus 20m. Now in the second part of this problem, we're going to take that algebraic expression and we're going to plug in. We're going to substitute the m for the number 2 because it says if Eric makes 2 batches of muffins. Again, we're going to follow PEMDAS. We're going to do the multiplication, then the subtraction. We get 460 minutes. The book usually likes to change times like this into hours and minutes, so this is 7 hours and 40 minutes. Let's take a look at a couple more examples of simplifying algebraic expressions. So I've got 2 algebraic expressions and I want to simplify both of them. Really it breaks down to getting rid of all the parentheses, combining like terms. So we're going to get rid of the parentheses in all these expressions by distribution, and now we're going to combine like terms. So our 2 answers are a plus 3b for the first expression, negative 10x minus xy for the second expression. Now let's take a look at a little bit more complicated of an example of evaluating algebraic expressions. Now we're going to start out pretty simple. We're going to plug 5 in wherever we see s. We're going to plug 3 in wherever we see t. Now remember PEMDAS. We need to take care of those powers first. So we're going to square the 3 on top, we're going to square the 3 on bottom. Now that that's taken care of, our next step would be to multiply. So we have to multiply the 2 and 5 and multiply the 5 and 9. So we have 10 minus 9 on top and we have 45 on the bottom. So our final answer that we box in is 1 over 45. Here's another example of evaluating an algebraic expression. It's actually a pretty big problem because across the top of this table they give us 3 different algebraic expressions. Down the side they give us 4 different numbers to plug in for x. Now I'm going to lay this out exactly like you should do it on your paper. I want to see this whole table and I really want to see those numbers plugged in for x. Don't just give me the number in each cell. Show the 1 plugged in all the way across. Then show the 2 plugged in. I'm really not too worried about the steps in between, but I really want to see that you're plugging the numbers in correctly. Now this is pretty much exactly how this problem should look on your homework. I want to see a table. I want to see numbers plugged in each cell in the table, and I want to see the final answer. Don't worry about boxing in. Let's face it, it's in a table. It's already boxed in individually. So, we're all set. Here's your homework problems again. So, we're all done with lesson 1-4. And I'll see you in class and I'll see you in the videos.